All right, dude, we are live. What's up, guys? This is Dan Keys, and today we are going to continue learning about um, async programming for the ESP32, and we're going to be using the Embassy framework, which is an async framework built for embedded programming. We are doing all this in Rust, by the way. I couldn't find a way to fit in the no std Rust part. But yeah, we are using no std Rust, and that's what we are doing today. We are going to be continuing focusing on Embassy. It's kind of a I need to find a way. I wonder if I should get Gemini to generate the Embassy example for me. Uh, eh, Hold on. I wonder if I should get Gemini to generate the Embassy example for PC. I should say that. So that way I can like create a separate project and import Embassy into that project, add Embassy as a dependency in that project, and practice Embassy in that way, practice async programming in that way. I don't know how much different it would be from doing it on an embedded device. Aside from the fact that if I'm doing it for the ESP32, I'm going to be using RTOS in in ESP in the ESP crate. So that's the, how do I say this? That's the runtime that gets used, that runs on the ESP32. This is the runtime that uh, would be handling all of the async tasks and stuff like that. So if I'm practicing directly on the ESP32, I would be using ESP RTOS. But if I'm practicing on PC, I'm probably going to be using some other runtime. They probably have something for PC as well. They have mentioned that yes, you can practice this on the PC, and yeah. So that's what I want to do. Now I've been making some good progress with the content pipeline. I decided not to go further with that whole what do you call it? Wait, give me a second. I need to close this and then open and open that up. Yeah, I've been making some good progress with actually I don't think I have made progress with that. Well, okay, I've made a bit of progress in that I haven't really added extra functionality in there any more than what we currently have, which is where feed in you can feed in the VOD file and the manifest file, and based on what the manifest file says, FFmpeg is going to be invoked a bunch of times to slice out clips from the VOD file that you specify. Now, I'm slowly developing my own workflow for this because something that I realized is that, so okay, the idea was supposed to be that I slice out all of these clips, and the clips, quote unquote clips, these are what Gemini considers clippable moments based on the analysis of the transcript. And something that I noticed is that first of all, the timing tends to be a tiny bit off. It's not always perfect, which is fine. It's off, sometimes, but it's also being like sliced up in between like discussions of things. Maybe I should change the prompt and ask Gemini to give um, clips that are anywhere between 3 minutes and 10 minutes. I also don't know if I should be doing longer clips because it seems like 3 minute clips do perform well, or around 3 minutes. Though I feel like even if I go slightly higher, it's not gonna be that bad. Though on platforms like Instagram, um, the the platform itself explicitly tells you that if you're posting reels and the reels happen to be longer than 3 minutes, then they're not going to be pushed out to newer audiences. So, or they're not going to be pushed out to a newer audience. So it's mainly going to be seen by your own audience. And if you don't already have a bit of an audience, then I'm guessing nobody is going to be seeing that reel. So if I'm posting these clips in order to get my channel's name out there, and in order to actually get the clips out there, at least on Instagram, the clips need to be lower than or shorter than 3 minutes. So I don't know if that whole 30 seconds, because currently the criteria that I gave is like it should be anywhere between 30 seconds and 10 minutes. The clip can be anywhere between 30 seconds and 10 minutes. So Gemini gives like you know, varying lengths, which is great. I was looking for that. I wasn't looking for specifically less than 3 minutes, but I have to experiment. I have to see how shorter videos perform, how longer videos perform, because I don't think a whole lot of people want to watch, you know, a whole 10-minute thing, unless the 10-minute thing is packed with information. I don't think people want to sit and watch that. Something that could help this situation that I'm talking about is if I use that silence detect mechanism that Gemini was mentioning, um, if I use the silence detect filter, because the idea there is I'll set up this filter with certain parameters and pass in the VOD along with this filter, definition, the filter that I've set up. I'll pass that in as well. And what was I saying? Yeah, I'll pass in the VOD. I'll pass in the filter definition with the various parameters and stuff. And what this is supposed to give out as output is the sections where it detects that there's silence. So based on its output, I will then write a Python script to parse that output and manually slice out segments from the original VOD, um, and then stitch them together to produce a properly edited clip. So this is definitely going to be a separate this is definitely going to be a separate script. I'm not going to try and squeeze this functionality into the current script. The current script, where it's at, it's good. It's a lazy clip extractor. I'm going to leave it at that. We have a manifest, we have a VOD. We pass both the manifest and the VOD into, or well, if we are going in order, we pass the VOD and the manifest into the script, and then the script reads the manifest, and based on the manifest, it slices out sections from the VOD using FFmpeg, and those become our clips. So I usually get anywhere between 25 to let's say 40 clips. I told Gemini you can generate up to 50 clips. I figured that would be good. Okay, no, hold on. I told Gemini you can generate up to 50 clips. However, I am prompting Gemini 4 times to do this because I get Gemini to analyze the VOD in 25% segments. So I'll go from 0 to 25%. I'll tell Gemini to analyze 0 to 25%. And then based on what it has analyzed, I'll tell it to, tell me clippable moments. So it produces that one output. Then in another conversation, I say, okay, analyze from 25% to 50%. And then, again, we repeat the same process based on what you analyze. Tell me what the clippable moments are. Then I do 50% to 75%. And then I repeat the same thing again. And then 75% to 100%. And I repeat the same thing again. So then I get four different JSON outputs. And then I stitch them together manually. And that is the clip manifest file. I then feed the VOD and the clip manifest file into the Python script, and that, based on the clip manifest, the script then slices out those sections and produces a directory of maybe, anywhere between 25 and 35 videos. And then I just go through those clips. So after going through those clips, sometimes I might decide. So far, actually, that has been the case. I haven't used the entire clip as it is. In various situations, I determined that I might want to stitch multiple clips together. So when I see three or four clips, or two or three clips that I feel like should, be stitched together and they're already nearby each other, then I look at their timing in the manifest file. And based on their timing, I calculate what the start and end time is supposed to be, and then I slice out that entire thing. And so far, I've gotten a couple of clips out of that. I will say this: the workflow is a bit more manual than what I was thinking, and the output, I haven't used the output, the immediate output, I should say. I haven't used the immediate output in the same way that I thought I would. I guess maybe because I just figured that, I have more. Um, I have better information in other clips that I want to, or rather, maybe I figured that by stitching multiple of the small clips together, I can, give more information in one video. There are definitely clips that like, they give like small bits of information here and there, and maybe I should consider also, uploading some of those clips, because not all the clips have to be 3 minutes long. Maybe some can be 30 seconds or a minute or something like that. So at some point, I'll probably find some clip like that within the output. But so far, this is where I'm at right now. Right now, I read. No, right now I go through the clips that have been produced, and this is still shorter than going through, the entire VOD, if I'm being honest, because there's a little more context. There's a name. There's like a, what do I have open here? So this is the clip manifest. I can show you the indexed version. Here I was working on the, what do you call it? Actually, I almost forgot to do something here. Give me a second. Okay, that's fine. Um, okay. And one more thing I think I need to do is refresh the feed. Okay, so um, what was I? Oh, yeah, this. Why was I talking about? Oh, yeah. So, this is still better than, at least in my opinion, or maybe it just seems that way to me because I've, already put a bunch of work into this tool. So maybe I'm just convincing myself that this is a lot easier than sifting through the entire VOD. I honestly don't think that sifting through the entire VOD would be easier. I feel like this is a lot more productive because for example, going through all the clips that have been produced, the clips are like cut out, right? It's not like the entirety of the the stream. There's the clips have, and this is one advantage of having like small chunks of clips. It's that there will often be like a bit of gap between the clips, and so I don't have to sit through that entire thing. So this way, what I get is multiple. I get essentially like a timeline with highlights of conversations that we are having, and there's also in between, like regardless of what the title might say, the title gives me an idea that yeah, this might be something I might be interested in checking out. But also sometimes within these clips where I'm expecting some other information, I might give out some other completely different information. And so then that I might want to, expand the clip and make it a little longer so that the other information gets added in as well. But yeah. I mean, so far I like the workflow that we are following here, and I'm most likely going to be improving this workflow. Right now, the idea is going through these clips to determine what I think is clippable, and out of each stream, even if I get like one or two clips, that's great. That's amazing. I'm not expecting, a whole bunch of clips out of each stream, even though, the output does actually produce a whole bunch of clips. Where's the output? Here. Even though the output is like a whole bunch of clips, like you can see here. Um, I don't know why this is black. Oh, it's the editing, not the editing. It's the fact that oh, never mind. I was about to say that it's the fact that I did that copy stream thing. It's the because I had mentioned earlier that if we use the lazy method, we are not re-encoding the entire video, and because we are not re-encoding the entire video, the beginning of the video it might not necessarily always it might have a glitch. It might have like a frozen frame or a black screen or something, and the same might be the case at the end of the video. You never know like what's gonna happen there. So I was about to say that yeah, maybe that's happening here, but no, it was just the fact that it hadn't loaded the preview yet. Okay, so uh actually, now that I think about it, I I was seeing the black screen, but I'm now realizing that you guys don't see the black screen. You see the screen perfectly fine. I completely forgot that I'm on Tmux, and I'm um the window that you guys are capturing, or the window that's being captured so you guys can see it. I'm not sending the input to that window specifically. I'm sending the input through another terminal to that session, but not directly within that terminal. So that's why I was seeing the black screen, and you guys were not seeing a black screen, which is great, awesome. You are seeing a gray screen though, because well, you're seeing a fully gray screen because my network is struggling. Um, but it is what it is. I can't really do anything about that. Now, um, what else? What else? I spent like pretty much all of yesterday, after yesterday's stream, I spent most of the time just working on I spent most of the time working on the content pipeline. The next script that I'll need to work on in the content pipeline is this silence detect mechanism. And what that's going to do is it's going to make the clips shorter. It'll be essentially, if I manage to do this right, and that's a huge if I manage to do this right, it'll essentially give me an automated way of doing jump cuts. Yeah, yeah, that's it. It'll give me an automated way of doing jump cuts. Dude, this would have been so much easier. Doing the jump cuts thing would have been so much easier if I was using the Instagram edits app, because that application has a bunch of very useful video editing features. The problem is it's mainly meant for portrait mode videos. And so far, the videos that I'm posting are all landscape. They're not portrait. I haven't really considered, how I'm going to change them into portrait. I'm also not really seeing too much of a reason to change them to portrait, if I'm being honest. Um, I mean, one reason would be to make things bigger, but then the problem is because um, I'm streaming in landscape. In order to make it portrait, I would have to do manual editing, manual like placement of or manually selecting regions of the video, I should say. That would be something interesting to work on later on. That could be a feature that I add to the content pipeline at some point in the future, where I'm able to define a region of I'm able to define a region of the video that I want to be captured. I'm 100% sure FFmpeg is going to have a cropping sort of thing, and that might even be part of the filters thing. Like that might be achievable through filters. I'm gonna have to get Gemini's help very heavily for that. But for the time being, I just want to kind of get the ball rolling in terms of posting content on social media. So for the time being, I'm not really paying too much attention to cropping. I'm also not paying too much attention to what do you call it? The silence detect thing. There's also the fact that like I have to spend some time testing things. I have to develop that entire functionality, not the silence detect thing, but like what I do with the silence detect result. I have to develop that functionality. That would be interesting though. That would be interesting to look into. I feel like one problem I might run into there is that it might be slightly slow because I'm gonna need to re-encode the entire video. So I don't want to do that with. I mean, I could, but I don't know if that's the best idea. I don't want to do that with the original VOD. If because the way I'm imagining this is that it's going to be like I'll get the output from silence detect, and then I'll feed that into my Python script, and in the Python script I'll have logic that goes through the entire VOD and finds the segments that are specified in the silence detect output, and based on that it picks chunks um, that it wants to what do you call it, export. It's going to pick chunks that it wants to export. It's not going to export like individual ones as separate files. It's going to use those timestamps that I provide to decide which segments of the video it wants to pull out and stitch together. And all of this stuff is definitely going to require re-encoding. It's not a good idea to um, like stitch all of this using the lazy slicing method. Um, that being said, I can use the lazy slicing method because okay, if we are talking about having to re-encode, right? That long VOD has to be decoded first before it can be, before we can pull data out of it. It has to be decoded first. So if it's a long VOD that's being decoded, and we are somewhere in like the middle of the VOD, that's going to take a very long time. That entire process is going to end up becoming very tedious. What I could do is I could stick with my current workflow. My current workflow is basically just like I mentioned. I have the clip manifest, I have the VOD. I'll feed both the VOD and the clip manifest into the lazy clip extractor, which is um, this. I'll feed it into this script, and this script is then gonna for each clip in the clip manifest, it's gonna the script is gonna produce one video. It's going to go through the entire VOD, find the timestamps that are provided, the start and end timestamps, and then based on that, it's going to slice out the video and export it as its own separate video. And it's going to repeat this for every single clip in the clip manifest file. What I could then do is once I go through all of these clips and I determine that, okay, I want I want a couple of these clips stitched together. So I want to go from this time to that time, and then I export that slightly longer clip after I've done my calculation. I can then feed, I can then run the silence detect algorithm on this newly exported file, which is only going to be like 3 or 4, maybe 5 minutes in length. And then I can also, based on what's been detected from this file, I can, what do you call it? Based on what's been detected in this file, I can then have it have FFmpeg decode this entire file and pick out the timestamps that it wants, and then produce a new video, but with proper re-encoding. Um, so that method could definitely work out. I feel like, because yeah, and then I could also, dude. So I'm wondering this. I'm wondering if I should try. So I'll do this with the next VOD because I'm already going through the first. Um, I don't know. In 29, as in the 29th of March. In 29, I don't know if I've gone through all of these clips already. I feel like I have. I feel like I have gone through a bunch of these clips because there's relay mentioned here. I exported something with relay. Then one of these clips is um in one of these clips I was showing uh the work by a person named Mohit Bhoite, or I still don't know if I'm pronouncing his last name right, but Mohit. This person does what's called free-formed sculptures. These are essentially so okay. The idea is that there are these sculptures that this person makes, but these sculptures are made with electronic components and modules, and usually there's a microcontroller as well. Well, okay, not always. Sometimes they're bare bones circuits, but even then there's like fairly complex functionality that the person makes with it. But yeah, it's made. This sculpture is made out of peripherals, various types of wires or brass. Brass. What do you call it? It's like a wire, but like it's a harder kind of wire. So you can like create a sculpture out of it. You can bend it in whatever way you want. It's not really soft like copper wires. And there's electronic components, there's modules, there's a couple more things. This person makes the entire sculpture using all of these things, and the interesting thing is these sculptures are working circuits. The entire structure is usually the circuit. And it's amazing to see the stuff that this person comes up with. So I was just showcasing that in one of the previous, actually in this stream, the 29th of March. This stream I was showcasing this person's work. Oh, here it is. There, I was showing one of the, not one of the, some of the images. But yeah, yeah. I could, so I was about to say that I could, because the next two VODs that I have to work on are the 30th and 31st, and that'll be the end of March. So further from that point, we start from, I think, 2nd of April, because I missed the 1st of April, and so I lost the VOD. Um, the 2nd of April, actually, I don't remember if I missed it, or I might have missed it, because even within April, I lost 3 or 4 VODs, unfortunately, because I became late to download them from Twitch. But yeah, yeah. Once I'm done with the 30th and 31st, then we can move on to, you know, then we can move on to April. So I'm wondering if I should experiment with the timing. If I should tell Gemini that um, do anywhere between 3 minutes and 10 minutes, rather than telling it to do anywhere between 30 seconds and 10 minutes. I don't know. I don't know. I don't know if telling it to do like longer clips is going to be beneficial for me or if it's going to end up wasting more of my time, because having the clips divided into so many chunks which I can then very easily, sift through, it seems to be a little more productive than watching the entire longer clip. In the end, I could decide to, export what would be considered 3 or 4 clips combined. I'll calculate what the time is supposed to be, and then I'll export that. And in that, there's going to be, a lot more content. But I feel like I'm being a lot more productive with this workflow where it's producing all of these clips, and then I go through every single clip and I decide if I want to maybe stitch stuff together. But yeah, dude, that's what I've been up to. For now, let's open up our project here. Let this thing load up, and let's get back to learning about Embassy. Real quick though, I need to take a short break, and fortunately, I started the stream earlier today, so we have another, like, in addition to me stepping away for 2 or 3 minutes, we have a good like hour and 15 minutes to go. So hopefully we should be able to make a good chunk of progress there. So I'm just going to switch to BRB um, there, and I'm going to mute my mic, and I'll be back in 2 or 3 minutes. Okay, I'm back. Let me just get this feed refreshed and then we can continue. Right. So far this is our actually give me another second. I need to set my phone on charge because I'm currently also looking at my chat on my phone. Okay. All right. Right. Now, yesterday we were going through this. We were also gonna go through this, and yeah, I'm kind of not sure where to begin in terms of practicing this. So okay, let's just start reading this. Okay, right, a basic embassy application. So you've got one of the examples running, but what now? So we don't have one of the examples running. We do have an example set up. I don't fully know how. I mean, okay. In the book, we have the Blinky example, and there's a couple of small differences here. I mean, there's a couple of small differences from, a non-embassy application. Here we have ESP RTOS, which provides the runtime for our async tasks. And we also have, I'm not sure what this is doing. What is this supposed to be doing? Because also there's spawner mentioned up here. Spawn some tasks. Oh, is the idea here basically that do something with it? Otherwise, yeah, that's probably why. It's to prevent the unused. It's to prevent the unused variable warning. So if I undo this and save it, now we don't get an unused variable warning. Okay. Um, then, so what are we, where is, oh, yeah, another way to avoid that warning is to just put a underscore before the name. I forgot about that. Yeah, Rust has that thing where you can, if it's going to be an unused variable and you know that it's going to be unused, then you can just put a underscore before the name, and that way Rust Analyzer is not gonna it's not gonna complain. I don't know if it's a Rust Analyzer or Clippy. One of these two complains. I think it's a Rust Analyzer. They complain that it's an unused variable. So I mean, yeah, pretty much the same thing, right? This what we've got going on here is the same as having an underscore before the name. Fine, great. And then down here, oh, this is interesting. It says info hello world. What is this? I don't think this would have been mentioned if we didn't have the print line thing set up. I need to look at, um, hold on. How do I do this without something getting overwritten? Okay, fine. We'll select that, do test O1, and just come in here. In here, we want unstable. Okay, let's not do embassy. Um, you know what? You know what I should do? Okay, so we are using definitely we're using the backtrace thing. I don't know if the code for that has been set up or if I have to do that manually. Yeah, because in a regular application, I believe it does set up the panic handler. in my case, in my bare bones application, the one that we were using, previously for the one that we built from scratch throughout, this book. Um, what was I saying? The one that we built from scratch from the beginning when we started reading this book. Throughout reading this book, we added more and more to that project. In that, I don't think I had set up a panic handler. And I did also notice that anytime the code was meant to panic, oh, this answered my question. Log info. Is log coming from, this says log oh 04. I wonder if that log is coming from log oh 04. A lightweight logging facade. The log crate provides a single logging API that abstracts over the actual logging implementation. Okay, libraries can use the logging API provided by this crate, and the consumer of these libraries can choose the logging implementation that is most suitable for its use case. If no logging implementation is selected, the facade falls back to this. I get the feeling that I'm pronouncing this wrong. Um, Hold on. Is facade pronounced as um, facade or um, facade? Because I'm spelling because wrong. Because I've I've mostly heard the latter, but I'm now seeing the word being used to describe the Rust log crate in embedded in ESP32 no STD Rust programming. So I'm wondering if I'm pronouncing it right. Okay, you've been hearing it correctly. The word is pronounced facade. Okay, rhyming with facade and odd. Okay, okay. It's trying to explain it to me like phonetically. Um, what was I saying? Oh yeah, I was reading this. Sorry, I zoned out for a second. The confusion often stems from the fact that it's a loan word from French. Okay, in French, it's the C has like a thing beneath it. In French, that little hook under the C called cadella, no, cedilla. I'm probably butchering that word as well. Tells you to pronounce it as a soft s rather than a hard K. Okay, so it's the sound of s instead of k. So facade. Yeah, yeah. Instead of facade, it's you would say facade, but then how does the R part come in? Well, I mean, okay. Um, sure. While English often drops the accent mark in casual writing, the pronunciation remains the same. Why is it used in Rust and programming? In the context of the Rust log crate or software architecture in general, a facade is a specific design pattern. It's actually quite a poetic name once you break it down. The literal meaning, the face of a building, especially the principal front that looks onto the street. It's the outward appearance that hides the complex structure behind it. That seems like an abstraction layer. That seems like an abstraction layer or a helper method in a way. Um, okay, the programming meaning. A facade is an interface that provides a simplified view of a complex body of code. The facade pattern in NoSTD Rust. When you use the log crate in an ESP32 NoSTD environment, you are interacting with a facade. Here's why. The interface. The log crate provides the macros you know and love, like info, warn, and error. The complexity under the hood, the hardware ESP32 doesn't inherently know how to print, quote unquote, print a log. It might need to send bits over a UART or save them to flash memory. The swap. The log crate acts as the front end. You write your code against the log API, and then you plug in a specific logger, like ESP printline, behind it. Your application code doesn't need to know how the logging is actually happening. It just sees the facade. Okay, okay, that's good enough for me. Great. All right. So let's continue reading this. So in our okay, so the log thing, we have info here. You know what? We'll upload this. We'll upload this, and we have a timer set up here already, right? So we can just do a toggle kind of thing. So let's set up um yeah, okay, let's set up the LED here. So let LED, oh, let's do LED 12. So it's our red LED blinking. Equals, what was it? Output, I think. Yeah, output new, right? And then peripherals dot GPIO 12. And then initial level is supposed to be level. Wait, what did I type? Level, GPIO level, and we want to do low. And then the next is config. What was it? Config.default, I think. Or are we? Oh wait, no, we already have a config here. No, wait. Oh, output config. It's not just a config. Okay, this is different than the config that we, well, created up there. Okay, all right. Then in here, we want to do, so in loop, okay, fine. It's gonna print out the thing in a loop. Every 1 second, we want the thing to toggle on and off. So we're gonna do LED 12 dot toggle, and then we have our timer here. We'll explore this in a bit. For the time being, oh shit, yeah, I need to quit this. Wait, so I enabled this. I also, so okay, this is the log crate. What we were looking at was from the log crate. Then we have ESP backtrace as a panic handler. I need to look into that as well. I need to create a situation where we are purposely gonna introduce an error. And I feel like the best way that I can do that is, at least the best way that I know how to do that right now, is by giving a PWM channel the wrong values, configuring a PWM timer with the wrong values. Let's escape, escape. Are you sure you want to quit? Yes. And then we want to do cargo. First, let's do a cargo build and make sure that this builds properly. Oh shit, it's building the entire thing from scratch. Okay. All right. In the meantime, while this is happening, we can go back and look at the code. So in the code, we have timer. Oh God, wait, stop. Actually, no. This is gonna build and then it's gonna throw an error. I forgot to make this LED mutable because the state is being changed. So let this finish building. Um, After that, actually, hold on. Oh, wait, no, this is not going to compile because, yeah, it's supposed to be mutable. That's shout out, Russ borrow checker. Actually, is it the borrow checker? It's not the borrow checker. Shout out whatever the system is that checks for mutability. Now I can run this again, and this time the build should be quicker. Great. So the build is done. Now we do run. Was there any like configuration that I had to do? I don't think so. Like in order to get no, it's got the right device. I do need to remember this though that we do have to do some configuration when it's a brand new system. Okay, so two amazing things happening here. First of all, we have our log crate, and this is printing values back. I am curious about something. Could we print? Actually, I did set up a printing thing, didn't I? I'm pretty sure I set up a printing thing. How do I look at the code without the entirety of the project loading up with Rust Analyzer? Um, Hold on just a second. Let's go in here. Let's use bat. Bat src bin. Why is bin not working? Oh, src bin main. Okay, all right. So, um, I was wrong. We did have a panic handler. Holy shit, we did have a panic handler. I just wasn't doing anything in the panic handler. That was the problem. Oh God. All this time I was thinking that we didn't set up a panic handler. And actually, if we go back here, I do remember the tutorial made us set up a panic handler. There's a dedicated section for the panic handler, and it explains why the panic handler is necessary. Holy shit. The whole issue here was that I hadn't set it up to do something proper. Um, that's why we weren't getting, any errors popping up. I need to try, what is this? This is panic info, right? Um, so two things. First of all, we have wait, um, in here we have the what was it? It was backtrace. Yeah. In here we have the backtrace thing. We also have print line, which is interesting. So if I use, oh, wait, info and so info warning and error belong to log, and print line is now being implemented by this one. Wait, back up. I'm seeing log oh 04 in here as well. These are features. Was this the log that I was thinking about? I'm confused now. Uh, no, hold up. Select that, do that. Okay. Now in here, use the log crate to print messages. So I did select that. I know that I selected that. And we do also have log, but why am I not seeing log in here in dependencies? Wait, is this it? You're joking. I missed it. It's because I was expecting every dependency to be in this format. It says log here. And I was also assuming that this log was somehow part of this. That's why I missed it. This is log. This is basically what. this is what we enabled. So we have the log crate for printing messages, and additionally, ESP backtrace has the ability to print messages as well. I want to see what that looks like. Let's quit this. Okay. Instead of info, let's do print print line. This is from ESP print line. Now, ESP print line, what is ESP print line using? Hold on. Okay, print line is, so we have print line in backtrace. We also have just a separate print line crate. Let me try asking Gemini. Hey, so I created a Rust um, no STD project for the ESP32 using ESP generate. In the TUI, I checked the options to what were the exact things. Let's try that again. Let's do that, and okay. You know what? Let me just copy this entire thing. Um, Open that. All right. Yank. Okay. To use so and do so and so thing. All right. Okay, this is great, and the project was created. But now within the cargo.toml file, I'm seeing that there's the ESP backtrace crate with the print line. What's the exact thing? Okay, quit. Okay, with the print line feature enabled, but there's also an ESP print line crate in the file. So I'm kind of confused about who's doing what. I'd imagine that ESP print. Oh shit! Accidentally hit my thing. I'd imagine that the ESP print line crate is what's actually implementing the print line functionality, because the print line thing has to be sent from the ESP32 over serial back to the computer, right? And there it's going to be printed. I'm not sure what the ESP backtrace print line feature is supposed to do. Okay, Gemini responded saying it's a classic too many chefs in the kitchen feeling, but in the no STD Rust world, these crates actually have a very specific complementary roles. When you're working without a standard library, you lose the luxury of a default printline macro and a default panic handler, so you have to piece them back together manually. Here's the breakdown of who is doing what in your ESP32 project. ESP print line, the low level speaker. Think of the ESP print line think of ESP line as the foundational crate that knows how to physically talk to the ESP32's hardware, usually via the UART or JTAG serial port. Its primary job is it provides the actual implementation of print and print line macros for no STD. Then the bridge. It can also act as a logging binary for the log crate. When you enable the log feature in ESP print line, it allows the log crates macros info, warn, and error to actually output text to the terminal. Then ESP backtrace, the postmortem expert. The ESP backtrace is your insurance policy. It only kicks into high gear when something goes terribly wrong, i.e., a panic. Its primary job is it provides a panic handler function required by the Rust compiler for no STD apps. And the print line feature, this is where the confusion usually lies. When you enable the print line feature in ESP backtrace, you are telling it when the chip crashes, use ESP print line to format and shout the error message slash stack trace. Sorry, that was so hard to say for some reason. Shout the error message slash stack trace over the serial port. How they work together. Here's a hierarchy of how a message gets from your code to your computer screen. In standard logging, or for standard logging, the flow is you call info, that's within the log crate, and then the log crate uses the ESP print line, which does stuff over UART slash USB. Okay, okay, all right. So the log crate is using ESP print line. Then in a panic slash crash, when panic is called, then panic goes to ESP backtrace, which then goes to ESP print line, and then that goes to UART slash USB. Why both are in your cargo terminal file? You need ESP print line because you want to see the logs while the program is running normally. You need ESP backtrace with its print line feature so that if the program crashes, the panic handler knows which quote unquote speaker to use to tell you why it died. If you removed ESP print line, you couldn't print anything during normal operation. If you removed ESP backtrace, your code wouldn't even compile because no STD requires a defined panic behavior. Okay, all right. So now I guess I can follow this up with another question. Hey, okay. So now I understand this concept, but this raises another question for me. I've noticed that the boilerplate um, code generated by ESP generate didn't contain a panic handler function. Um, Yet my program compiles just fine. Is there some sort of predefined general purpose panic handler function function provided by ESP backtrace? I do see the what is it called? I do see the panic handler um, feature enabled in the ESP backtrace crate. You've hit on exactly how ESP backtrace makes your life easier. You're correct. Usually In a no STD environment, you are forced to write something like this manually. And this, in this case, is it's giving me an example of pretty much the code that we see in the browser here, or more specifically, this function. The magic of the feature flag, when you enable the panic handler feature in your cargo.toml, you essentially told the crate to include a pre-written panic handler function in its compiled binary. Because you have use ESP backtrace as, do I have that? Gemini can't see my code. So let me see if that's, oh, okay, Gemini guessed this, that I have this line. Use ESP backtrace as so and so. Um, where was I? Yeah, because you have use ESP backtrace as underscore or a similar import in your main.rs, the Rust compiler pulls in that crate. The compiler then sees the panic handler symbol defined inside ESP backtrace and says, "Great, I have exactly one panic handler for this project. Requirements met." What does its general purpose, quote unquote, general purpose handler actually do? It isn't just a simple infinite loop. It's actually quite sophisticated. When a panic occurs, the handler provided by ESP backtrace performs these steps. It halts execution, so it stops the current task immediately. It captures the CPU state. It grabs the current registers and stack pointer, and then it unwinds the stack. It walks back through the memory to see which functions were called leading up to the crash. And then finally, it prints the trace. It uses ESP printline to send a human readable backtrace to your console, telling you the exact memory addresses where the failure happened. Why use ESP backtrace as so and so? You might notice a line like so and so. Okay, in Rust, as underscore syntax tells the compiler, I want to link this crate and include its code in my final binary, even if I never explicitly call all of its functions in my code, any of its functions in my code. Without this line, the compiler might optimize the crate away. Oh yeah, because it's not being used in the code. Okay, okay. And you'd be back to that missing panic handler error. All right. Can you override it? Yes. If you ever wanted to write your own custom logic, like blinking an LED or performing a hardware wait, you can blink an LED when the thing panics? That's that's interesting. Hold on. Wait, that's interesting. Um, right. You would simply disable the panic handler feature and then write your own thing. But for 99% of development, the one provided by the crate is exactly what you want because it saves you from guessing why your chip suddenly stopped responding. Does the backtrace output you're seeing so and so? Okay, that's a question to continue. Wait, so I can actually blink an LED even in panic? Yes, you absolutely can. In fact, blinking a SOS LED or triggering a buzzer during a panic is a common pattern in embedded systems to let you know the device has crashed without needing a serial monitor attached. I did not know that, dude. Holy shit, I should keep that in mind. I should keep that in mind, but also right now, I want to try setting up something here. Hold on. Real quick. So we had okay, so where would it be? ESP um would it be delay? No, do we have a PWM thing? No, that's MC. Oh, LEDC. There you go. That's what we need. I'm glad that that was shown. LEDC. Let's just say as LEDC. So then I'll use this further on from this point. Here we are gonna create our hold on. So we'll do this hello world, and I want to see what that looks like. But also in here, let's set up. Does it have to be a mutable timer? I don't know. We'll do a high speed timer. HS timer 0 equals LEDC dot um there LEDC dot nope, that's not working either. LEDC, let's try that again. LEDC dot timer, is this a okay? Timer dot timer. I'm assuming this is the one. Timer dot new maybe? No, no. What was the code? I forgot what the code was. Oh, here it is. Output peripherals. This is not the code. Um, oh, LED fade. That's what I'm looking for. Right. We're looking for timer self timer. So timer dot timer and timer iFace. Should I just copy this? Maybe I should just copy this. Okay, wait. Um, okay, what did the example look like? So here we have, oh, we have to use the, what do you call it? Silver, is that what it was called? Silverfish? Is that, no, wait, is that what it was called? Silverfish. The term silverfish and turbofish. Okay. Um, okay, yeah, we have to use the turbofish syntax. So let's delete a bunch of these things. And then here we want to do LEDC dot um, low speed, high speed. We are going for high speed. Dot timer. Is this how we are specifying it? I'm not sure. Low speed. Oh God, dude. Wait, hold on. So we, okay. Right. All of our configuration is done in the configure method. So we have timer dot timer. Actually, it's not even, is it timer? Okay. All right. LEDC timer. Oh, what are we specifying here? Is it a clock source? No, it's the timer number. Number timer. Okay. Holy shit, that took so long. Right. HS timer dot configure. Right. What's the issue now? Oh, is it because I don't have mute? No, there's some other issue. I think I got this right. I'm pretty sure I got this right. Expected function found module. There's an error somewhere here. Give me a second to dude. Okay, hold on. Let's simplify this. I'm in an effort to try and rewrite this code. It's wasting a bunch of time. I think I'll just copy this entire thing. So let's copy everything LEDC related. Okay, yank, come here, um, paste. Hopefully that works. All right, so we've got a problem here. Timer is defined multiple times. So we can do timer as LEDC timer. Okay, and then we will copy this entire code. So let's do a low speed timer. And we might as well also copy the channel because that's going to come next. Okay. Let's yank that and come here. Paste. Okay. All right. Okay, rate. Rate has to be resolved. Is there an action that we can do? Qualify as ESP so and so. Okay, all right. Is that good? That's good. And then we have an issue here as well. Fail to resolve drive mode. Okay, qualify it. We have an issue here. Replace qualified path with use. Wait, what is the issue here? Expected value found module LEDC. Why is that a problem? LEDC dot is it supposed to be like this? No. Oh wait, I did create an LEDC thing here. I just remembered that. Let mute LEDC so and so. Okay. I don't know. Do I have the right thing here? Yeah, new peripherals dot LEDC. And then we need to set a global clock as well. So LEDC dot set global clock and so and so. Set global clock, LEDC, ls global clock source. I think that's it, right? Holy shit, this is taking so long. trying to recreate this little example. I'm just not so familiar with the API, and so I started forgetting things, and then there's all of these problems. You might want to use the following variant. Expected value found so and so. Okay. Um, oh, oh, um, I'm supposed to use a variant. Okay. All right. Right. So here we have an issue. It's saying it ESP print line, print line. Are we good now? Yeah, we're good now. Finally. Holy shit. Oh, wait. One last thing. I need to purposely cause an error. What is something that would not work out? Um, yeah. A low. So we'll do 5 hertz, but we'll only give it like 3 bits. That should, that's wrong. There. That should cause an error, definitely. Yeah. Um, okay. Well, it printed. It printed. Let's scroll up. Panic. There you go. Divisor. This is what I was looking for. This would have been very helpful. So this panicked at line 56, which is at our unwrap. So it does mention, I mean, unwrap is supposed to either use the, what is it, error? No, okay. It's supposed to return the okay or panic. So if there's an error, then it's supposed to panic. Is it called okay? Oh, yeah, yeah, it's called okay. So it returns the contained okay value, consuming the self value. Because this function may panic, it's generally discouraged. Okay, all right. All right, cool, cool. So now we know that we could have used this. Um, right. So I can delete all this now. And we can come up here and delete this. And now we can resume with testing out our async code. So now let's see what print line, how print line behaves compared to info. Okay, so we have our information being printed using print line. Info, I believe info is from log, and log is also using print line. So all we've done here is manually call print line, manually import the print line function from print line. Other than print line, they also have um, print and something to do with printer. And then there's a logger as well. Okay, so I'm not going to get into any of that just for the sake of, keeping things simple. Okay, all right. So the next thing we need to look into. So here we have await. This suspends execution until the result of a future is returned. Awaiting a future will suspend the current function's execution until the executor has run the future to completion. Read the async book for details on how async slash await works. You know what? We'll do that. I'm gonna open up. Um, Actually, they also mentioned the async book here, not here. They mentioned it, and I'm pretty sure I also opened it up. Can't remember where it was though. Let's close a bunch of these things. Yeah, there it is. Async. Let's close that, close that, close that. Async. Oh, this section does not serve as an async tutorial or teaching material. For those purposes, visit the official async book. Okay, let's visit the official async book. But there's some interesting information here as well. I didn't know that there's something called Arial OS. I like that name. Arial OS is an operating system for secure, memory safe, low power IoT. It builds on top of various projects from the embedded Rust ecosystem, including ESP-HAL. Uh, Arial OS focuses on tight integration, adding missing OS features like a multi-core scheduler, secure networking, portable drivers, and a unified build system. The result is a powerful alternative to C-based real-time operating system solutions, but in pure Rust. It has great integrations with Embassy and can be used together with Embassy in various ways. I am interested in this. I'm still going to stick to bare metal, but I'm interested in checking this out. Oh, here it is. And it's actively being maintained as well, which is great. Arial OS is an operating system for secure, memory safe, low power Internet of Things, IoT. Okay. It is based on Rust from the ground up and supports hardware based on 32-bit microcontroller architectures such as Cortex, Cortex-M, RISC-V, and Extensor. For a quick overview of our motivations, okay, cool. Goals and design. Arial OS builds on top of existing projects from the embedded Rust ecosystem, including Embassy, ESP-HAL, DFMT, ProBars, sequential storage. I should look into this. Sequential storage and embedded test. Let's look at that as well. While those tools provide high quality building blocks for a wide range of embedded applications, such projects do not provide a high level of integration that developers know from contemporary C based operating systems for microcontrollers, such as Riot and Zephyr, for instance. Okay, okay. Sequential storage, a crate for storing data in flash memory with minimal need for erasing pages. I should look into this later on. Storing data in flash memory with minimal erase cycles. Okay. Embedded test, a test harness and runner for embedded devices. All right. Okay, all right. Let's get back to this. So we have async programming. I don't think this is going into. Wait, this says that this is currently going through a rewrite. Okay, let's see how that is going. All right. Okay, I mean, we can read this anyways. We can get an idea of how to do async programming in Rust. Okay, I hope this goes into like bare bones async and it doesn't immediately tell us to use Tokyo. Let's take a look at this. Hold on. Okay, processes and threads. Okay, all right. Oh, good. Okay, it's teaching us like concepts and stuff. I don't think this would be too different from like what the tech is like right now. So in terms of this being apparently an outdated book, I think we should still be able to accomplish a lot with this. Yeah, yeah, I'd say so. Async and await. Okay, let's look at some code. This is bringing up Tokyo. This is using Tokyo. Okay, I need to find a different resource, or maybe I'll go over this and see if there's like I need to talk to Gemini about this. Like if I wanted to do async stuff bare bones just for the sake of getting just for the sake of having experience of doing it bare bones. If I wanted to do async stuff bare bones, then how how would I go about this? Yeah, because this is using the Tokyo main macro, and then that does whatever code generation it has to do. I want to do this with, I mean, to be fair, I wanted to learn about Tokyo as well. I was learning it through Gemini, right? I could instead just go through this book, because this is gonna go into all of those topics as well. It does stop at a certain point, which is fine because I think I'll get a decent amount of my information from this part one. I don't know how complete it is because I was seeing like to do mentioned in a couple of places. Running async code. Okay. This is all bullet points. This is bullet points. Okay. Oh, none of this stuff has been made. All right. Okay. This is all past a certain point. A lot of this is bullet points. And I guess that's where, the currently in development aspect of it comes in. It's currently in development. Okay. All right. You know what? Right. Okay. Here's what I'm going to do. I am going to raid out. And then we will continue this async stuff tomorrow. We're gonna further explore the example code and um, also look at the stuff being mentioned in the embassy book. Sorry, I was trying to figure out what I was trying to say. Let me see if okay. Usually Twitch would give me like recommendations for people to raid into. Give me a second. Oh, I think I see someone doing Unity game development. That's interesting. Okay, I'm just opening up a couple of streams to see which one to raid into. You know what? This person seems chill. Um, Let me see if they have like any settings that prevent a raid. No, dude, we're good. Okay, all right. So we're gonna raid into this person. They're doing some sort of something art related, something I don't know. I think I'm seeing them doing like something with stickers. Um, but yeah, yeah. So that's gonna be it for today's stream. We made some good progress today. Off stream now, I have to continue with the content pipeline. Um, I could continue working on the content pipeline and work on like, the silence detect thing, or I could get back to reading the Forest Mims book because I need to get back to that as well, right? And then I can just use the content pipeline as it is right now to create content for the social media stuff. And then at a later time, I could work on um, the next part of it, which is like creating like a jump cuts kind of thing. Okay, my timer is running out for the raid. Um, yeah, that's gonna be it for today's stream. I'm gonna stream again tomorrow, hopefully, and we will continue learning about async programming for the ESP32. Uh, so I hope you guys have a nice day, and I'll see you all next time. Peace.